Good evening and welcome to my channel. Today we'll be looking at logic gates. What is a logic gate? A logic gate is a device performing a Boolean logic operation on one or more binary inputs and then output a single binary output. Types of logic gate. There are 7 different types of logic gate. We have the AND gate, the OR gate, the NOT gate, the NOR gate, the NAND gate, the exclusive OR gate, and the exclusive NOR gate. We'll be looking at this gate one after the other. The AND gate. You can see the AND gate. We have the 2 input AND gate. We have the 3 input AND gate. For this gate, the minimum input it can have is 2. So it can be 3, it can be 4, and so on. But the minimum it can have is 2, and it always have a single output. The question now is that how does this gate operate? The output of this gate will be high if and only if all the inputs, the first input and the second input and any other input that it will have are high. So if the inputs of these gates, all of them, if they are all at high, which means level 1, the output of this particular gate will be high. If any input is low, the output is low. So if any of the input, no matter the number of input it has, if one of them is at level 0, that means the output will automatically be low. Let us look at the truth table of a 2 input AND gate. So this is the truth table of a gate. To know the number of states that the gate will operate, the formula is 2 raised to the power n, where n is equals to the number of input. So if the gate is having 2 input, that means 2 raised to the power 2 is 4. That means that it can operate in 4 different states. So we start counting that state by saying we have a 0, 1, 2, 3. That is the 4 state. 0 is 1 state, 1 is 1 state, 2 is 1 state, 3 is 1 state. 0, 1, 2, 3, they are all in decimal. So if we convert 0 to binary in 2 bits, we have 0, 0. If we convert 1 to binary in 2 bits, we have 0, 1. If we convert 2 to binary in 2 bits, we have 1, 0. And if we convert 3 to binary in 2 bits, we have 1, 1. So we have our input A and B as 0, 0, 0, 1, 1, 0, and 1, 1. So you see that when input A is 0, B is 0, the output is 0. When input A is 0, B is 1, the output is 0. When input A is 1, B is 0, the output is 0. And when A is 1, B is 1, the output is 1. So that is to tell us that for the output of this gate to be high, all the input here must be high. The Boolean expression for this particular gate is Q, which is the output, is equals to A times B, which is the multiplication of the input. The next gate we have here is our OR gate. You can see the symbol of the OR gate. Take note of how the diagram is. And this one is 2 input, this one is 3 input. So the operation of the gate. The output of this gate will be high if any of the input, the first input or the second input or any of the inputs are high. The output of the OR gate goes low if and only if all the inputs are low. So let us see that on the truth table again. We have the 2 input gate, and this is our truth table. have four different states: 0 0 0 1, 1 0, and 1 1. So like you can see, when the input is 0, A is 0, B is 0, output is 0. When A is 0, B is 1, output is 1. When A is 1, B is 1, output is 1. When A is 1, B is 1, output is 1. So you can see that for the output of this gate to be high, any of the inputs must be high. If all the inputs are low, the output will be 0. The Boolean expression for that gate is the output Q is equals to the summation of all the inputs A plus B. Take the next one, which is our NOT gate. You can see the symbol of the NOT gate. Apart from the this, it is only this gate that have only one input. All the other gates, they have the minimum of two input, but for this particular gate it has only one input and the output remain one. It is called an inverter, but to differentiate it from other type of electronic inverter devices, it is sometimes called a NOT gate. So preferably we'll be calling it a NOT gate. So you can see the truth table of this NOT gate. It has only one input, so that means it have two different states. Either it is 0 or it is 1. So like we said, it's a NOT gate or an inverter. So that means if you put in 0, the output will give you 1. And if you put in 1, the output will give you 0. The Boolean expression for that is the output Q is equals to the inverse of the input, which is this. The fourth gate we'll be looking at is the NOR gate, or it is sometimes referred to as not OR. Simply meaning that this is your OR gate. At the output of the OR gate, a NOT gate was added, making it a not OR gate or a NOR gate. Take note of the symbols, the way it is drawn, and so on. The output of this gate goes low if any of the inputs are made high. The output is high only when all the inputs are low. So it is a direct opposite of the OR gate. As you can see, when the input is 0, A is 0, B is 0, output is 1. When A is 0, B is 1, the output is 0. When A is 1, B is 0, output is 0. When A is 1, B is 1, the output is 0. Which simply means that for the output of this gate to be high, all the input must be low. So it is a direct opposite of your OR gate. As you can see, this is your OR gate and this is a NOT gate added at the output to make it a NOT or a NOT gate. So to see the Boolean expression that represent the gate, Q is equals to the summation of the the summation of the output or bar. The summation of the output or bar. That is the Boolean expression that explains that. We now look at the NAND gate or the NOT AND. It's the same thing, the AND gate with a NOT added at the output. The output will be low if and only if all the inputs are high. So for the output of this gate to be low, all the input must be high. Otherwise, if any of the input is low, the output will be high. So again, it's a direct opposite of the AND gate. So you can see when input A is 0, B is 0, your output is 1. When A is 0, B is 1, your output is 1. When A is 1, B is 0, your output is 1. And when A is 1, B is 1, your output is 0. So for the output of this gate to be high, one of the inputs must be high. So if all the inputs are high, what you are going to get is a low output. Again, the Boolean expression that explains that is the output is equals to the inverse of the multiplication of all the output. We now look at the exclusive OR gate. It is sometimes referred to as XOR or EOR. This is the symbol for the gate. So the output of this gate is high if the inputs are at different logic level. So if the inputs of this gate are at different logic level, for example, some of them are 0, some of them are 1, that is only when the output will be high. Again, the minimum input all the other gates can take apart from the NOT gate is 2. So it's only the NOT gate that can take a minimum and a maximum of 1 input. But for all other gates, the minimum input they have is 2. They can have more than 2 and so on and so forth. So again, like we said, for the output of this gate to be high, the input must be at a different logic level. So some of them can be 0, some of them can be 1. So we see that from our truth table. This is the symbol, this is the truth table. When A is 0, B is 0, I see that the output is 0. When A is 1, B is 1, mean that they are the same logic level. See that the output is 0. But when A is 0, B is 1, different logic level, output is high. And when A is 1, B is 0, different logic level, the output is high. The Boolean expression that explains that is the output Q is equals to A exclusive or B. So the last gate we are looking at is the exclusive NOR gate. Again, a NOT gate was added at the input of the exclusive OR gate, making it an exclusive NOR gate. So it sometimes refers to as XNOR or ENOR. So the output of this gate will be at logic level high whenever both input are at the same logic level. So if all the input are at the same logic level, whether they are 0 0 or 1 1, that means the output of this particular gate will be high. So let us see it here, the truth table. When A is 0, B is 0, see that the output is high. When A is 1, B is 1, the same logic level, output is high. But when A is 0, B is 1, the output is low. And when A is 1, B is 0, the output is low. So the Boolean expression for that is the output Q is equals to A exclusive or B or by making it an exclusive NOR gate. So for you to properly study the lecture, be sure that you understand it, there are some task set for you to try. Just go through them and make sure you leave your answer in the comment section. If you find this video very interesting, I want you to follow me on Facebook. I want you to subscribe to my YouTube channel, and I also want you to share this video with your friends that you feel that it will be of benefit to them, and also leave the answer to these questions on the comment section, and you will get a response of the correct answers to these questions. Thank you.